So unless you've been living under a rock and are interested in the AI space at all, you will know that we've gotten two pretty big model drops in the last week or so. One, DeepSeek-R1 by a company in China, and the other o3-mini by ChaptGPT. I have a history at this point of evaluating coding standards for AIs, so by popular demand, I've done some experimentation on both DeepSeek and the newly dropped ChaptGPT o3-mini, specifically with respect to generating code. I've got results to show you today, and in a few more days, I should have posted a follow-up video that talks about what I think DeepSeek and this generation of stuff might mean for software developers going forward, so subscribe if you're interested in seeing that. So the short version, because I don't want to be one of those people that draws everything out until the end of the video, in my testing, DeepSeek is very close to as good as o1, which is to say, it's not very good at straightforward but unusual things that humans can apparently figure out pretty well. All three of them totally failed to write a fairly straightforward but non-trivial program in the Zig programming language that would even compile. Even given multiple attempts, they couldn't get something that would compile. And this isn't some huge thing. We're talking somewhere between 500 lines, give or take 50% or something like that. Then I moved to some more well-known tasks in more common languages, and it became clear that o1 is better than DeepSeek. Not a lot better, but it is better. For example, I switched to the Go language using the same problem that they couldn't get to compile in Zig. They all got the thing to build, although they all required multiple attempts to get something that would even build. Only o1 got the correct answer, and I'm not convinced it wasn't just a lucky guess. On the next step of the problem, both o1 and DeepSeek failed though, and I eventually just got tired of dealing with it. o3-mini seems to be about the same as DeepSeek, that is, not as good as o1 at the things I asked it to do, just slower and more verbose. So in short, the things can regurgitate Stack Overflow answers pretty well, but when it comes to programming that requires reasoning or thinking, they're still all pretty much crap. This is the Internet of Bugs. I'm Carl. I've been a software professional for more than 35 years now, and I think the current internet is buggy enough without a bunch of AI-generated coding slop being pushed into production by people who don't know any better, or people that should know better but just don't care enough. For the next section of this video, I'm going to be talking about my code generation experiments with DeepSeek-R1, ChaptGPT o1, and to a lesser extent, ChaptGPT o3-mini High. The reason I'm going to spend as much time with o3-mini High is that it's really slow. And it doesn't seem to be any improvement over the current full-blown version of o1. Maybe it was rushed, maybe coding was skimped on to make the mini version, I don't know, but I don't think it really matters. It's just a preview more or less. I think it's less interesting than comparing flagship models. If you really want more o3-mini focused testing, let me know in the comments. As with my previous experiments, I'm going to be using a site called CodeCrafters to provide the challenges for the AIs to handle. They are not sponsoring this video, they have not seen it or had any input into it, although I do have an affiliate link, which should be on your screen now, that will earn me a little bit of money if you use it to sign up for their service. No pressure, but if you want to be able to prove to yourself that you can solve coding problems that the very best AIs can't figure out, at least not yet, feel free to go to the link below. The structure of the challenges is a series of incremental step-by-step prompts that you solve, push the code to a Git repository, and then it's graded by a server and feedback is returned to you. If the test passed, you can go to the next step, which will build on the previous steps until you get to the end, and by then you've built your own simplified version of some open source technology. It's a great way to test AIs because they're specifically designed to be challenges for programmers, and they're not on some list of top interviewing questions that the AIs have already memorized. And the site gives statistics on how people who have already attempted the challenge did, so you can kind of see where the AIs would fall in that range. I also want to stress that, although these are challenges for programmers, these are way simpler than what mid to senior level programmers do on a daily basis. The problems we work on in the real world aren't handed to us one step at a time with clear instructions. The first challenge I used was build your own SQLite. So first off, SQL is something that all programmers should be at least somewhat familiar with. It's not seen as really sexy now, but there's a pretty good chance that every paycheck you've ever received and almost every bill you've ever paid has passed through a SQL database at some point. So it's pretty pervasive and it's worth learning about. The second reason I picked SQLite Challenge is that it's one of the very few places in real life that binary trees are actually used that people touch. The whole balance a binary tree thing is cute in a leak code interview question context, but it's quite different to actually be parsing these things from files, having to deal with potential error cases and managing metadata and overhead. This challenge doesn't even scratch the surface of what all SQLite can do, this one only deals with read operations and only straightforward ones at that. The real difficult stuff that SQLite can do goes far beyond what this challenge is, but the challenge is still quite instructive. There are people that I've worked with that can easily answer the B-tree whiteboard questions that have been utterly confused by trying to apply it in the real world. I had a problem once where there was a SQLite file that was getting corrupted, and I asked an ostensibly bright CS graduate on my team to figure out what the corruption was using the corrupted file in the file specification documentation. Let's just say it didn't go very well. In any case, as has become my habit lately, when I first started AIs on the challenge, I asked them to start with the Zig language. So Zig is a cool language. It was first released in 2016, and it first cracked the top 50 languages on the TOBE index in April of 2023. So it's not a common language, but it is well documented and it's hardly obscure. The AI seem to think they can program in Zig, but not so much. Codecrafters, he hands each one a working Zig program, as well as the instructions for how to modify it for the next stage. And according to Codecrafters, 98% of users who attempt this stage complete it. And that puts all three of these AIs in the bottom 2%. Now, granted, most programmers aren't the kind that would try this kind of challenge in the first place. So it's not the bottom 2% of all programmers, but it's the bottom 2% of what I would argue is a representative sample of the good programmers. So then I switched to the exact same challenge, but in the Go language, which last I saw was something like number 7 in the TOBE index. So it's not a language that's as likely to already have a solution to this problem already in the training set as something like Python. The good news is they all managed to get the Go program to compile eventually. So Go has this feature where unused variables are not allowed and they generate an error. That's kind of a pain in the early stages of writing code, but I've come to appreciate it when trying to maintain the code over time. It's a well-documented feature, and Go programmers know to omit or comment out the names of variables that aren't going to be used yet. And not just that, any decent human programmer who gets an error that says that one variable that's unused is generating an error will proactively check to see if there are other unused variables and remove them too. But the AIs tend to not do that. Often it will get an error that one variable is unused and it will remove just that variable without checking to see if others are also unused, which means an annoying cycle of getting rid of unused variables one line at a time. Now that's pretty typical of my experience with AIs. They know the thing you told it and they can react to the specific thing they were told to do, but they can't then go the extra step and realize the implications that it has for the rest of what they're working on, and they can't take proactive action to preemptively correct the next things that are going to go wrong. They're just not that smart. And this is even the so-called reasoning models like O1. That hasn't really changed since the earlier ChatGPTs that I was working with. So then once all these AIs got Go programs that would actually compile, they all got the wrong answer. So O1 got the stage 1 answer right after a couple of tries, but I think it might have just gotten lucky as its code is pretty bad. Specifically, its error handling was atrocious. It removed most, if not all, of the log fatal statements that Codecrafters had given it to start with. So if something unexpected happened, it would stop. And in several places, it either called break or just returned nil if an error actually happened. So any useful error information that Go passed to it was just thrown away. As a consequence, when something went wrong, instead of stopping or logging there was a problem and therefore having a clue where to look, it just blindly returned to 0 when the correct answer was 4, with no indication that anything might have been amiss. O1 also really liked to remove useful comments for no apparent reason. DeepSeek's code was actually better written, in my opinion, especially when it comes to error checking. The problem that it had was that it missed that it needed to seek past a 100-byte header before it read the variable it was supposed to return. I eventually got tired of it trying and failing, and I just fixed that by hand so it could go on to the next stage. I'm not going to go into much more detail about the actual code quality here. I'm planning a video for channel members to discuss that, since it's unlikely to be interesting to most of the people that are watching this. I gave up on o3-mini as it wasn't improving and each failed attempt was taking forever. I got through like 6 attempts and was like, okay, I'm done. Once stage 2 rolled around, both DeepSeek and O1 gave wrong answers again. They were supposed to return the names of the tables in the database, and what each returned contained at least some part of the string of table names, but I just didn't feel like going through that again. So I just called that a fail and switched to something easier. So to better see the differences between DeepSeek and O1, I stayed in the Go language, but I switched to Codecrafters' Build Your Own DNS Server challenge. DNS is one of the core principles on which the internet is built that every internet developer should at least be somewhat familiar with. So it's a useful thing to discuss, and it's ranked as a much easier challenge on Codecrafters, and it would hopefully be a better representation of what the AIs might have a clue about what to do with. Unlike the previous challenge, which involved not just SQL in general, but one specific implementation of SQL, namely SQLite. This DNS challenge involves no particular implementation, but just the core simple parts of the protocol, the DNS protocol, that had been largely unchanged for decades. So I was pretty confident that they were at least familiar with it. At this point, it became clear that o1 was a much better coder than DeepSeek. It blew right through the first 4 stages that I gave it on the DNS challenge, step at a time, while DeepSeek got stuck on step 2. Once it became clear to me that the changes that DeepSeek was making to try to progress had nothing to do with the actual problem it was having, it was just changing, like one time it just changed a comment, like that was going to help. So I just called it. So the benchmarks might say that DeepSeek is better, and I certainly prefer its code, but when it comes to actually getting the correct answers to the challenges I gave it, o1 is clearly the winner. That said, DeepSeek is an open model, and OpenAI's, ironically, is not. Also, DeepSeek is faster and a lot cheaper to use. So at least for the time being, I expect that I'll be a lot more likely to use DeepSeek for any coding tasks that I might want to save time by delegating to an AI, at least if they're simple enough that I think the AI might have a chance of handling them. Soon, I'll have a video up about what I think this might mean for the programming profession for the next couple of years, so stay tuned if you want to see that. And until then, thanks for watching, and let's be careful out there.